Hello, Professor. My name is Shirdina. The project I have done for this capstone is about the breast cancer prediction, and I'm going to discuss about this project in the coming slides. The outline of the presentation. So, in this presentation, we'll discuss about the introduction, the concept of this project and the introduction of the Wisconsin dataset, and we'll discuss about the exploration, statistical analysis, visualizations, and pre-processing, training and testing the data, and also using of various machine learning models, and finding out which is the best among those models. Yeah, and this conclusion for that. So yeah, about the introduction. Breast cancer is one of the most common cancers among women worldwide. In 2020, it was estimated that the breast cancer accounted for approximately 30% of the newly diagnosed cancers among women in the United States. Early detection can help in providing effective treatment options and also improve the survival rate. So in this presentation, we'll discuss about the various machine learning models and their performances while predicting a tumor, and also whether it is a benign or a malignant one. So the overview of the data set. Uh, this data set contains around 500 and data of 569 breast cancer patients. So for each patient, there are 30 features that have been extracted from the digitized images of the breast tissue. So these features include various informations like the radius of the tumor, texture, perimeter area, smoothness, and a lot of things. So we're targeting the target variables in the data set, are either M or B. Means B means benign and M means a malignant one. So yeah, and the data set we are taking is about the Wisconsin data set, and this is one of the famous data sets for predicting the breast cancer. Yeah, by using various machine learning models, it was used widely in a lot of places. So here is the graph. Here it shows how many cases of benign were there and how many cases of malignant were there. So the one indicates the benign cases, it's almost around 300 and above 350, and the blue one indicates the malignant ones. So here the cases were divided into two categories, and one is a benign and one is a malignant one, and here is the count. Yeah, so here is the graph which shows that the difference between the mean area and the mean smoothness for the malignant and benign cases. So here we can clearly observe that for the benign cases, the mean smoothness it's like same as the malignant ones, but the mean area is very small when compared to the malignant ones, which clearly indicates that the overall spread of the benign tumors is a bit less when compared to the malignant ones. So the blue ones here easily indicates that the mean area is very much higher than the benign cases. So the amount of the tumor that's going to spread in the body is wide, and the effect it's going to show is more than the benign ones. So this one shows about the radius mean, texture mean, perimeter mean, and area mean for the benign and the malignant cases. So almost the radius mean, texture mean, and perimeter mean is almost similar for both the cases. But when it comes to the area mean, the malignant ones take more area when compared to the benign ones, which indicates the spreading is more. So about the testing and training, yeah, we are splitting the data to train and test in the machine learning models like into two separate subsets. One for training for the machine learning model, and one other for its testing for its accuracy. So in general, a common split is to use like 80% of the data set is used for the training, and the other 21 is used for the testing. This can vary depending upon the size of the data set. So as we have only 569 samples, I'm taking 15% of the whole data set for testing. So this training and testing, this is very useful because this training data is used to fit the machine learning model to the data set. like during this training, the model will learn patterns, relationships between the features and the labels, and this includes, uh, selecting a suitable algorithm and tuning its hyperparameters to achieve the best performance. And we are going to use various uh, parameters to verify the accuracy of the machine learning model. uh, so next we are going to discuss about the various machine learning models we are going to use in this one. So the logistic regression. So it's one of the most commonly used machine learning models for breast cancer diagnosis. So it's a binary classification algorithm that models the probability of a binary response variable. It works by estimating the coefficients of linear equation that relates the input features to the output variable. So in this data set, we achieved an if accuracy of around 96% and a precision of 97 and an F1 score of 95.71. So the another model we are using is that it's the gradient boosting. It's a popular algorithm for classification problems. It's a algorithm that works by combining several weak learners to form a strong learner. It works by iteratively fitting models to the residuals of the previous models, and we got the accuracy of around 95% in this one. And when it comes to the k nearest neighbor, uh, it's a non-parametric algorithm that works by finding the k nearest neighbors to a test point and then classifying the test based on the majority clause of its k nearest neighbors. So we got around 96.5% efficiency in this one. And the next one is the light GBM. It's a gradient boosting machine. It uses a leaf-wise growth strategy to reduce the training time and increases the accuracy of the model. We got around 97% accuracy for this one. Uh, the last one is about the famous machine learning model, random forest classifier. So it's a very popular machine learning algorithm used for both classification and regression tasks. It's a learning method that combines multiple decision trees to make more accurate predictions. Each decision tree in a random forest is constructed using a different subset of the training data, and the final prediction is made by aggregating the predictions of all the individual trees. So, after this model, we achieve the highest accuracy, that is 98%, and this stands among the best in the machine learning models we used for this project. you know uh, I'm a favorite for this one because it's known for its ability to handle high dimensional data sets, and its robustness to outliers and noise of the data. The favorite thing about this one is it performs well on imbalanced data sets such as the Wisconsin data set, where there are so many the number of samples is there is a huge difference between both the samples. And we are using voting classifier, to measure the accuracy of this, and we find that the red random forest has the highest accuracy. Yeah, that's it, professor. I'm done. Like, if you have any questions, yeah, I'm free. Like, you can go through.